Question says, state for each of the following physical quantities if it is a vector or a scalar. So we have volume, we have mass, we have speed, acceleration, we have density, number of moles, velocity, angular frequency, displacement, angular velocity. Now, a vector quantity, we all know, is the quantity that has both magnitude as well as magnitude and direction both, and the scalar is a quantity which has only magnitude. So volume is the amount of space that is occupied by any object, and its magnitude is, its dimension is length times length cube, and length is not a vector quantity, so we can't say that it is a vector quantity, it is a scalar quantity. Now mass also doesn't have any direction associated with it. It is just a value with some unit. So it is also a scalar quantity. Speed is also defined as the length of the path divided by the time that it took, the time the particle took to cover that path. So the length of the path here is not a vector quantity, so it can also be said that scalar quantity. Acceleration is defined as velocity, change of velocity per unit time. Here velocity, acceleration equals to change in velocity divided by time. Here velocity is described as change in displacement divided by time. Now displacement is defined as change in position vector. So here we see that acceleration is a derived quantity of velocity, and velocity is a derived quantity of displacement, and displacement is a vector quantity which is defined as change in position vector. So here all these three quantities is going to be a vector quantity. So here we can say that acceleration is a vector, and velocity is a vector, as well as displacement is a vector. Now density is defined as mass per unit volume, which is a scalar quantity, so it is also going to be a scalar quantity. Number of mole is defined as the amount of substance, which is a scalar quantity. It has only magnitude. That is how we can classify it as a scalar quantity. Angular frequency is just a number with the unit of hertz, so it can also be said as a scalar quantity. Here angular velocity again is a vector quantity. Question says, pick out the two scalar quantities in the following list. So there are given various physical quantities in which we have to figure out two scalar quantities among these. So we see here that force is a vector quantity, angular momentum is a vector quantity, work is dot product of force times displacement So it is a scalar quantity. Current is also a scalar quantity as it doesn't follow vector law of addition. So these two quantities are scalar quantities. The question says that pick out the only vector in the following list. So it has previously been stated that there is only one vector in the following physical quantity. So let us find out. You all know that temperature is a scalar quantity because it has got no directional sense. It is just a scalar value. Pressure is also a scalar quantity. Now impulse is defined as force multiplied by time. So it is force is a vector quantity here. So we can say that this is the only vector quantity that is present in the entire physical quantities. Over here we see that time is also scalar, power is also scalar, total path length is also a scalar quantity, energy is also a scalar quantity, gravitational potential itself is a scalar quantity, coefficient of friction is also a scalar quantity, charge is also a scalar quantity. So only impulse is the vector quantity over here. Thank you. The question says that state with reasons whether the following algebraic operation with scalar and vector physical quantities are meaningful. So let's assume that we have two physical quantities. The first one is a scalar as 4 meter per second speed, and the second quantity is scalar, another scalar, we have 4 kg mass. Both can't be added because they both have different dimensions, so this is not always going to be true. Second option, we have adding a scalar to a vector of same dimension. Let us assume that we have vector of 2 I cap plus 3 j cap meter per second. Since they both have same dimension, they both represent different physical quantity. One is speed and one is velocity. The speed doesn't have any directional sense, so we can't add it with a velocity which has a direction. So this is always going to be false. In the third case, we have multiplying any vector by any scalar. So let's assume that at t1 the velocity was 2 I cap plus 3 j cap. Now we say that at certain point of time, after certain time, the velocity doubled, so we will be multiplying with a scalar. Also, if we have to find out the displacement, we will multiply it with the scalar quantity of that is time. Let's say that 2 seconds, so we will get 4 I cap plus 6 j cap, which is displacement in I dimension and j dimension. So this is totally valid, so this is going to be true. And in fourth option, we have multiplying any two scalars. Two scalars can be multiplied. Let us say that the scalar 1 is again speed 4 meter per second, and the scalar 2 is 4 second time. So we have to find out the distance traveled by the particle in 4 seconds. So this will be multiplied to give us the third physical quantity, that is length, and it is going to be 16 meter. So this is totally valid. Now in fifth option we have adding any two vectors. For addition of two vectors, they should have same dimension, so it can't be true, just like adding in two scalars. So this is not always true. Now in sixth option, we have adding a component of a vector to the same vector. It's saying that you can't add this two component of a vector because they both are different. So it can be said that this operation is totally invalid. So this is false. Thank you. The question says that read each statement below carefully and state with reasons if it is true or false. The first is magnitude of a vector is always a scalar. So we first look at the magnitude, how it is calculated. So let's assume that there is a vector A with 2 I cap plus 3 j cap, where I cap and j cap is the unit vector along x-axis and y-axis. So the magnitude of vector would be 2 square plus 3 square. So it is always a scalar quantity, so it is true. Now each component of a vector is always a scalar. So when we see this vector, we see that it comprises of two component x component and component y component. So each component is an independent vector, which is 2 I cap and 3 j cap. So this statement is false because it is never a scalar. The magnitude of each component of a vector may be scalar, but not the component of a vector is a scalar. So this statement is false. Now in third option we have the total path length is always equal to the magnitude of the displacement vector of a particle. So total path length, here it is being talked about, is equal to the magnitude of displacement vector of a particle. So when we see the movement of a particle, let us assume that this is x direction, this is y direction, and particle started from the origin and it goes in this way and it reaches here. It started from point A and reached till point B. Now when we see displacement, so we have to compare the magnitude of displacement with the displacement vector here. So displacement is defined as the difference in the position vector of initial and final. So displacement vector would be vector B minus vector A. So assuming that B is the position vector at particle at point B and A is the position vector of particle at point A. Now the path length is the addition of it is the total length of the path that the body travels in the trajectory from position A to B. So from the definition we also know that displacement is the shortest distance between the initial and final points. So since the definition always contains, so when the particle is moving in not in a straight line from point A to B, it is always going to have a larger path length. So path length is always going to be greater than the displacement, greater than or equal to. Now the equality sign will only hold if the particle is traveling in a straight line, and also in the same and the particle doesn't change any direction. So this statement is false. Now in fourth option we have average speed of a particle defined as total path length divided by the time taken to cover the path is either greater than or equal to the magnitude of average velocity of the particle over the same interval of time. So the definition of average speed is path length divided by time, total time taken, and the average and the definition of average magnitude of average velocity is also the total displacement divided by time taken. So we from this relation we always see that since path length is always greater than that of the displacement, so the average speed of a particle is either always greater than or equal to the magnitude of average velocity. So this statement is going to be true. Now in the fifth option we have three vectors not lying in a plane can never add up to give a null vector. So from vector law of addition we know that, let's assume that there are two vectors, vector A and vector B. Now when we add these two vectors we will assume that vector B is here. So C is going to be the resultant vector or R is going to be the resultant vector. Now this addition of vector, this three set of vectors A, B and R, if it has to be 0, then the direction of R must be from point B to point A. since R is the resultant of the vector addition of A and B, so if we have to make this whole summation of three vectors 2 equal to 0, so we need to have minus R, and that too will only be possible if all three vectors are lying in the same plane. So in the present case we have A vector plus B vector equal to R vector. So if we have to make this three set of vector equal to 0, so we will add A vector plus B vector minus R vector equal to R vector minus R vector. So this will cancel out to be 0, and this set will have 0 value. So in order for this to be valid, all these three vectors must be in the same plane. That's how the triangle law will make them 0. So the statement that three vector not lying in a plane can never add up to give a null vector is correct, because if they are not lying in the same plane, then they can never be added up to 0. Thank you. So this is true statement. Question says that establish the following vector inequalities geometrically or otherwise. So we have been given 4 vector inequalities and we have to express them geometrically or by any other ways. And also we have to say when does the equality of these 4 conditions will hold true. So let us take the first case where we have been given the vector addition. So let us find out the formula of vector addition. So let us assume that there are two vectors A plus B. So the vector addition magnitude can be expressed as under root of A vector A square plus vector B square plus 2 vector A vector B cos theta. Now let us pictorially represent this thing. So here the theta values cos theta ranges between -1 to 1. Now let us represent it with graph. So this is vector A, let us assume that this is vector A and this vector B. So the addition would be somewhere like this, A vector plus B vector. Now the subtraction would be, if we invert this vector V, then we will get minus B vector. So this is minus B vector, and this will represents A minus B. Now this relation is going to be true for both the cases. Let us make it with different color. Yeah. Now this relation is going to be good for this will hold good for both relation. Now the difference would be just in this sign A minus B. All that matters is the theta angle between them. So in the first case, vector addition case, we had theta as like this. This was vector A and this was vector B. This was theta. And in the second case, we have vector A and just inverted vector B. So now this is the theta. So moving on to the first question, we have the magnitude of vector A plus B, like this value, is always less than or equal to the independent magnitude of this vector A and vector B. So the magnitude of this expression relies all on cos theta value. So as we have said earlier, the cos theta is varies between -1 and 1. So let us say that when cos theta is -1, so the magnitude of vector A plus B is going to be equal to the independent vector A. It is -1, so it is going to be vector A minus vector B and when it is when cos theta is -1, and when cos theta is plus 1, we will have a plus b equal to under root of yeah. So we see that maximum value that it can have is this is the minimum value that it can have, and maximum value it can have is this. So as expressed in the first question, it says that it is going to be either less than or equal to this expression. So we can see clearly that the maximum value that it can have is this, when cos theta is equals to plus 1 or cos theta equals to 0 degree. So the equality sign will hold when theta equal to 0 degree, and in that case we will have this relation to be true, and minimum it can go is a minus b. Now the second question also says that the magnitude of vector addition of vectors a and b is always going to be greater than a minus b. So we see that minimum it can go is a minus b, the magnitude of a minus the difference in the magnitude of both the vectors. So minimum it can go is this one. So this relation is always also true here. Now the equality will hold when cos theta equals to minus 1 or theta equals to 180 degree, or when both the vectors are in opposite direction. So here equality will hold when theta equals to 0 degree, and when theta equals to 180 degree, the equality will hold in second case. Moving on to the second part of the question, we have we have the vector subtraction a minus b. Now we earlier saw that vector subtraction is nothing but the change in sign of the second vector, in this case the vector b. So vector subtraction is represented by this. Also we saw graphically the angle change in vector subtraction. So if theta is the angle between the vectors addition, then the angle between these two vector after subtraction would be theta equals to 180 degree minus theta. Now theta dash, let us say it is theta dash and it is theta. So the rule will work same like before this expression. Now the difference would be simply the magnitude of vector a minus vector b would now be expressed as magnitude of vector a square plus magnitude of vector b square plus 2 vector a magnitude vector b magnitude cos theta. Now here theta would be equal to 180 degree minus theta dash, let us say theta 180 degree minus theta, because the angle has changed as we discussed here. So new angle would be 180 degree minus theta, and this would be the magnitude of vector a plus 2 vector a vector b. So cos 180 degree minus theta is going to be minus cos theta, so it is minus cos theta. Now this will turn out to be vector a magnitude minus vector b magnitude whole square. Now this will turn out to be vector a minus vector b. Now again it will represent it will matter if theta upon the value of theta. So if theta is equals to 0 degree, it is going to be this relation, and if theta is equals to minus 1, if theta equal to 180 degree, it is going to be the sign will change here, and it will turn out to be vector a plus vector b. So we saw from the previous case like that vector, if they both were both of the vectors were pointing in the same direction or theta was 0, then the value was a plus b, and in this case the value is when theta equals to 0 is a minus b. So the opposite equally we can say that the maximum value that vector a minus b can have is a plus b, or it will always be less than a plus b. So this condition we can say that the value, the equality will hold when theta equals to 180 degree, because the maximum that it can have is a plus 1, else it is always going to be less than that, and the least that it can have is a minus b, which can be said that which can be clearly seen in the option D when theta equals to 0 degree, like in this case. So now we can conclude the question by saying that when vectors are pointing in the same direction, the addition of vector is equals to the magnitude of addition of vector is equal to the independent addition of the magnitude of the vectors. If vector is pointing in the opposite direction, then the magnitude of vector is equal to the difference of the magnitude of the independent vectors. Now if the vector is pointing opposite of each other, the difference, the magnitude of the difference of the vector is equal to the addition of the independent vectors magnitude. And this, if the both of the vectors are pointing in the same direction, now the difference is going to be equal to the difference of the independent vectors if they are pointing in the same direction, like. So the question says that given a, b, c and d are 4 vectors and they are the summation of both of all the vectors are 0, so which of the statements are correct? So we have been given 4 statements. The first statement is a, b, c and d must each be a null vector. We all know that summation of vectors can result to 0, so they don't need to be, they can be 0 independently, but they don't need to be 0 independently for the summation to be 0. So the condition of must here is false, because let us assume that this is vector a and this is vector b, and let us assume that this is vector c, and this is vector d. So we can see here that the summation of all the vector a plus vector b plus vector c is coming out to be vector d. They both have same magnitude. Now if we subtract vector d from both the sides, vector a plus vector b plus vector c minus vector d equals to 0. So we see here that they all had finite magnitudes, but still they resulted in 0 upon summation. So this condition is false, stating that they must independently be a null vector. Now let's just go to the second question. The question is the magnitude of a plus c equals the magnitude of b plus d. Now since the given relation is this, let us move forward with that. A vector plus b vector plus c vector plus d vector equal to 0. Let us subtract vector b and d from both the sides. So we will have vector a plus vector b plus vector c plus vector d minus vector b minus vector d equal to minus of vector b plus d. Now we see here that vector b and minus vector b is there, so they both will result to 0 or null vector. Vector plus d and vector minus d is there, so they will result in null vector again. Now the left out would be vector a plus vector c is equal to minus of vector B plus vector D. So the question was the magnitude of A plus C equals the magnitude of B plus D. We see here that since the both the sides are equal, so their magnitude must be equal. Or since both the side of the vectors are equal, then the summation of A and C must have same magnitude to the summation of B and D. Now moving to the now this is correct, so we will mark it correct here. Moving to the next question, we have the magnitude of A can never be greater than the sum of magnitude of B, C and D. Now since this relation to be true, again we will subtract B, C, D from both the sides. Then we will have vector A equal to minus of vector B plus vector C plus vector D. So we see here that the magnitude of A is equal to magnitude of B plus C plus D for this relation to be true. So we can say that the magnitude of A can never be greater than the sum of magnitude of B, C and D for this relation to be true. Now let us go to the next question. This is true again. The next question says that B plus C must lie in the plane of A and D if A and D are non-collinear. So non-collinear vectors are the vectors having some finite angle between them. So let us assume that this is vector A and this is vector B and this is angle theta. So if theta is greater than 0, then it is going to be non-collinear vector. But if theta is equal to 0, then they both have same direction and they are said to be a collinear set of vectors. So the condition says that B plus C must lie in the plane of A and D. So let us pictorially represent this relation. Assume that this is vector B and this is vector C. Now B plus C would be somewhere like this, B vector plus C vector. Let us name this B plus C vector as M vector. Now we had relation A vector plus B vector plus C vector plus D vector equal to 0. This has to be true. We will see in the given condition. So the condition says that vector M must lie in the plane of A and D if A and D are non-collinear. So so now we have vector M, vector A and vector D, and it is being said that they must lie in the same plane for this condition to be true. We all know that for a set of 3 vectors addition to be 0, they must lie in the same plane. So this condition is true because M now carries B plus C. So B plus C plus A plus D must lie in the this M vector must lie in the plane of A and D for this condition to be true. Now in the second part of the question, it says that in the line of A and D if they are collinear. Now if A and D vectors are collinear, so let us assume that this is vector A and this is vector D. So now it is saying that the vector M must lie in the same line of vector A and D if vector A and D are collinear. So this is pretty obvious that the resultant vector will still have the same direction as that of A and D. So they must lie in the same line or same direction if this condition has to be true. So again the fourth statement is correct. Thank you. Question says that 3 girls skating on a circular ice ground of radius 200 meters start from point P on the edge of the ground and reach a point Q diametrically opposite of P. following different path as shown in figure 3.19. What is the magnitude of displacement vector for each, and for which girl is the displacement equal to the actual length of the path skate? So this is the figure of 3 girls A, B and C who are skating from point P to Q, and the diameter of this circular ground is 400 meter. As it is stated over here that radius of 200 meters, so its diameter would be 400 meter. Now we have to find out the magnitude of displacement vector for each. So we all know that displacement is equals to final position vector. Let us assume that for A it is A final minus A initial. Now we all know that the magnitude of displacement is going to be A final minus position vector A final minus A initial. So irrespective of the path taken, the position vector for all the 3 girls after reaching point Q is going to be same. So we can say that the magnitude of the difference of position vector of final point and the initial point is going to be same, or for each of the participant or for each of the skaters the displacement is going to be of 400 meter. Now the second question is, for which girl is the displacement equal to the actual length of the path skate? So since displacement is the least distance between the both initial and final points, in this case we see that girl B has moved from straight B to Q, whereas A and C has followed curved path. So the smallest distance would be the diameter of the ground, and that path has been traversed by girl B. So for which girl? For girl B, the displacement is equal to the actual length of the path skate by that girl. Thank you. The question says that a cyclist starts from center O of a circular park of radius 1 kilometer, reaches the edge P of the park, then cycles along the circumference and returns to the center along QO as shown in figure 3.20. So in this picture we see that a cyclist starts from point O, reaches to point P, then travels to point Q, then returns back to O. Now we have to find out, and it covers this distance in 10 minutes. So we have to find out net displacement, average velocity and average speed of the cyclist. So we know that net displacement, let's first talk about net displacement. So we know that net displacement is equal to the final position minus initial position, and we see here that cyclist started from point O and reached here at the same point O. So net displacement is going to be 0. Now let us talk about average velocity. So average velocity is described as net displacement divided by time taken, and we saw that net displacement is 0, thereby average velocity is also going to be 0. Now let's calculate the average speed of the cyclist. So average speed is defined as path length divided by time taken. Now path length is going to be starting from O to P, it would be R radius, plus it would be the quarter of the circumference. So we can say 1 by 4 multiplied by 2 times 22 by 7 times radius, that is 1 kilometer, plus again 1 radius. This much of kilometer is the path taken. Radius is 1, so we can substitute directly here 1. Now the time taken is 10 minutes, and we can write that in hours as 10 by 60 hours. Now upon the calculation, we will get 21.4 kilometer per hour. Thank you. The question says that on an open ground, a motorist follow a track that turns to his left by an angle 60 degree after every 500 meters. Starting from a given turn, specify the displacement of a motorist at the third, sixth and eighth turn. Compare the magnitude of the displacement with the total path length covered by the motorist in each case. So we have to calculate the magnitude of displacement as well as path length or the distance from the starting point at third, sixth and eighth turn. So let us create the trajectory of the motorist. Motorist start at point A, it moves to point B, traveling 500 meters, turns 60 degree left, reaches point C, again turns 60 degree left, reaches point D, again turns 60 degree left, and reaches point E. It repeats, reaches point F, and then again reaches point A. So we have to calculate till 8th turn. So we will mark the turns. Started at point A, B would be the first turn, C would be the second turn, third turn, fourth turn, fifth turn, sixth turn, again seventh turn and eighth turn. We have to calculate distance as well as displacement at third, sixth and eighth turn. So let us begin calculation of the third turn. So third turn is at point D, started from point A. So the total path length would be 500 meter. Path length would be AB plus BC plus DC, and that would give us 1.5 kilometer. So the distance is going to be 1.5 kilometer. And the displacement would be calculated by drawing a straight line from point A to D. Now we see that this is a hexagon. So together this both will make 180 degree, and this is 120 degrees. So this is going to be 60 degree, and again this is going to be 60 degrees. So the length AD would be AB cos 60 degree plus BC plus DC cos 60 degree, and that is going to be AB cos 60 degree is 500 meter into 1 by 2. It means 250 meter plus 500 meter plus again 250 meter. This is going to be 1 kilometer. So the displacement would be 1 kilometer. Now let us calculate for sixth turn. So we see that at the sixth turn, the motorist is at the starting position, like at A. So its total displacement is going to be 0 because initial and final point has become same. So its displacement is going to be 0. Whereas distance would be AB plus BC plus DC plus EF plus FA plus EF. It also means that 6 into 500 meters, and that would be equal to 3 kilometers. So the distance would be 3 kilometers. Now let us calculate for 8th turn. 8th turn is here at point C. So here we see that the distance is AB plus BC, which is equals to 1 kilometer. Sorry, distance would be after whole path, it covers AB plus BC twice. So after covering whole 3 kilometers, it covers 2 times 500 meters, 1 kilometer. So it is going to be 4 kilometers. And the displacement would be a straight line joining A to C. Now this is in this triangle ABC. We see that BC is equals to AB, so the angle would be same, opposite angles would be same, and since angle BCA is 120 degree, so angle ACB and angle BAC would be 30 degree each. Now since we have to calculate AC, that would be equal to AB cos 30 degree plus BC cos 30 degree. That would give us 500 cos 30 plus 500 cos 30. So this will become 500 multiplied by 2 times cos 30, which is going to be 0.866, and this will give us 1000 times 866, and that is equals to 866 kilometers. So displacement is going to be 866 meters. Sorry. And AC is making an angle of 30 degree from the initial direction, that is AB. Thank you. The question says that a passenger arriving in a new town wishes to go to the station to a hotel located 10 kilometers away on a straight road from the station. A dishonest cabman takes him along a circuitous path 23 kilometers long and reaches the hotel in 28 minutes. So what is the average speed of the taxi and magnitude of average velocity? Are those two equal? So here the case is of a tourist, a passenger who has arrived to a station and he has to go to a hotel. So let us assume that this is the station, this is the road, and since the station is 10 kilometers away on a straight path from the hotel, so we can say that this is a hotel and this is the straight path and the distance is 10 kilometers. Now the case here is that the cabman was a dishonest man. So what he did was, instead of going on a straight line, he started moving on a circuitous path, like moving, revolving like this, and then reached here after 28 minutes and traveling 23 kilometers. So he charged him for 23 kilometers. 23 kilometers and 28 minutes. So we have to find out average speed and average velocity. So we all know that average speed is defined as total path length divided by total time taken. In this case, the total path length is 23 km and time taken is 28 minutes. So we will be writing it 23 kilometers divided by 28 divided by 60 hours. Now this will turn out to be 49.3 km per hour. Now in second part B, we have to calculate the average velocity, magnitude of average velocity. So average velocity is described as displacement divided by time taken. Now displacement in this case is suggested that since the straight line separation between these two hotel and station is 10 kilometers, and displacement is also the least distance or the straight line distance between the 2 points. So its displacement would be 10 kilometer divided by how much time it takes, 28 minutes, divided by 60 hour. So it would give us 21.4 kilometer per hour. So here we see that magnitude of the speed and magnitude of velocity is different. And why? Because speed depends upon the path traveled, and whereas velocity depends upon the displacement. That's why these two have come out to be a different value. Thank you. The question says that the ceiling of a long hall is 25 meter high. What is the maximum horizontal distance that a ball thrown with a speed of 40 meter per second can go without hitting the ceiling of the ball? So the question is talking about a projectile motion of a ball which is thrown at a certain velocity in a long hall which is 25 meter high, and we have to find out that what is the max. So attaining the maximum height, how far can the ball go? So here we see in this animation that there are 3 balls with different angles. It is thrown with the same velocity. Now the video is trying to compare the different angle and its impact on the horizontal range. Where does the ball fall? So we have 3 equations. Time to attain the maximum height is at first we will understand the velocity components. So velocity is making an angle of theta 1, theta 2 or theta 3 degree with the x direction. Now the x component of the velocity is going to be v cos theta, and y component is going to be v sin theta. Now the maximum height and the time of flight will be dependent upon the vertical component of the velocity, which is v sin theta, and the range will depend upon the time of flight and the horizontal component of the velocity, that is v cos theta together with v sin theta, because there is the time is the factor. Now we see that in equation number 3, that is the horizontal range. The horizontal range depends upon sine 2 theta, which is a cyclic in nature. We know that sine theta values will vary in the first coordinate from 0 to 1. Now from 0 degree to 90 degree it varies from 0 to 1. Now 90 degree is the maximum. So when theta is equals to 45 degrees, sine 2 theta will become 90 degree. Now at theta equals to 45 degree, this value is going to be maximum. So we can say that at theta equals to 45 degree, the horizontal range is going to be maximum. But in this question, it says that the ball should attain maximum height. So the approach is going to be a little bit different here. Let's move towards the question. So the question, we had been given the height, maximum height, and the velocity of the ball. Now from maximum height we can find out the theta angle at which the ball is thrown. So after using this equation that we had in the previous slide, we get that theta is approximately equals to 33.36 degrees. Now using the range formula, we can calculate the approximate range of the ball using this theta angle. So at this theta angle, the ball is going to touch the ceiling, just touch the ceiling, and then at that theta angle, what is going to be the range is found out using this equation, and the range is 151 meter. It is approximately equal to 151 meter because we have an approximation over here also. Thank you. The question says a cricketer can throw a ball to maximum horizontal distance of 100 meter. How much high above the ground can the cricketer throw the same ball? So the question is talking about the maximum height that the cricketer can throw the ball given the maximum range. Now here there are two cases that is being discussed. The first is of maximum range and the second is of maximum height. Now what common in both the cases is that the one who is throwing the ball, that is the cricketer, is same and he is applying the same energy. So in both the cases, velocity of projection is going to be same. Now we know from the previous exercise that horizontal range can be given from the expression v square sine 2 theta upon g, where the maximum range can be calculated at theta equals to 45 degree. So the case where he can throw the maximum horizontal range of 100 meter is when theta is equals to 45 degree. Now vertical height can be calculated with this equation v sine theta square divided by 2g. So now let us solve the question. So as per the given data, we have maximum horizontal range of 100 meter. Now using the equation v square sine 2 theta divided by g, we found out keeping sine 2 theta as 1, since sine 2 theta, where theta is 45 degree, will give us 1. So we found out that velocity is 31.3 meter per second. Now using this velocity, we can find the maximum height that the ball can reach. Now for finding the maximum height, we will put the angle of projection as 90 degree. So using this equation, we get maximum height as 49.9 meter. Thank you. The question says that a stone tied to the end of a string 80 cm long is whirled in a horizontal circle with a constant speed. The stone makes 14 revolutions in 25 seconds. What is the magnitude and direction of acceleration of the stone? So here the stone is not changing its magnitude of velocity. So the motion is uniform circular motion, and also it is moving in a plane. Now for a uniform circular motion, there is always an acceleration acting towards the center of its rotation, that is known as centripetal acceleration, which is given by the expression omega square r, where r is the radius of the circle in which it is moving and omega is the angular velocity. Now as per the given data, we can find omega by multiplying 2 pi by dividing 2 pi with at first we will find out the angle So it will make 2 pi times 14 radians, because it is moving in a complete circle, and it makes that in 25 seconds. So its angular velocity is going to be 3.52 radians per second. Now the acceleration can be calculated to 9.92 meter per second square, and its direction is going to be towards the center of rotation for the entire duration of motion. Thank you. The question says that read each statement below carefully and state with reasons if it is true or false. The first is net acceleration of a particle in circular motion is always along the radius of circle towards the center. So it is saying that when a particle is moving in a circle, let's assume it is particle P, then its net acceleration is always going to be towards the center of the circle. But we all know that this is only true when the particle is moving in a uniform circular motion, that is, the speed of particle remains constant, that then only it is possible that its acceleration is towards the center. Otherwise, when it is changing its speed, then it will have certain magnitude of acceleration in other direction also. So this is false. Now the B part says that the velocity vector of a particle at a point is always along the tangent to the path of the particle of the point. This is true. Let us see how. So let us assume that the particle is traveling in a curvilinear motion like this. Now our point of reference is this, that is O. Let us assume that at time t the particle is at, the position vector is r dash, and at time t dash position vector is r dash. Now the displacement vector is going to be in the direction of r dash minus r. This is the position vector that is going, because r dash minus r vector is going to be this vector, and for very small angle, or for angle theta tends to 0, or for very, as it is saying that the velocity vector of a particle at a point, so this angle, let us assume that it is very small, so this will be the tangent. The displacement vector is tangent. Now velocity is the derivative of this displacement vector with time, so velocity will have the same direction as that of displacement, so displacement vector is also going to be the tangent of the path. So this is true. Now C part says that the acceleration vector of a particle in uniform circular motion averaged over one cycle is a null vector. Now we all know that in uniform circular motion the centripetal acceleration always act towards the center of the circle. So at any point it is of same magnitude and acting towards the center of the circle. Now for every point there is a counterpoint, its direction. Now let us assume that this point is M and this point is N. So at point M it is acting in downward direction, whereas at point N it is acting of same magnitude in upward direction, so they both will cancel out each other. Now this will happen for each and every point on the circle, so that's why its average is going to be always 0, so it is true. And this is only true if the motion is uniform circular motion, that is the speed is constant. Thank you. The question says that the position of the particle is given by this vector 3t I cap minus 2t squared j cap plus 4k cap in meter, where t is seconds and coefficients have proper unit for r to be in meters. So the here I cap, j cap and k cap are the unit vectors along x, y and z axis. So we have to find out the velocity and acceleration of the particle. So we all know that velocity is defined as derivative of position vector with respect to time, and acceleration is defined as derivative of velocity vector with respect to time. So the velocity vector can be represented as derivative of 3t I cap would be 3 I cap minus 2t squared j cap would be minus 2 into 2t j cap plus, this is constant, so it is going to be 0 meter per second. This will result out to be 3 I cap minus 4t j cap meter per second. Similarly, we can find out acceleration by deriving this with respect to time. The derivative of velocity with respect to time will give us the acceleration. So here t3 is constant, so it is going to be 0 and minus 4t. So dt by dt is going to be 1, so it would be 4 j cap meter per second square. Now we have got the vector for velocity and acceleration. The second part of question says that what is the magnitude and direction of velocity of the particle at time t equals to 2 seconds. So it is asking at t is equals to 2 seconds, what is the velocity vector, its magnitude and its direction. So by substituting to this vector expression, velocity expression, we can find out the velocity vector, and that is going to be 3 I cap minus 8 j cap meter per second. So this is the vector, velocity vector. Its magnitude is going to be under square 3 square plus 8 square, and that will yield out to be 8.54 meter per second. 8.54 meter per second. And the direction, we also need to find the direction. So let us draw a coordinate axis where this is x-axis and this is y-axis. So the velocity component is minus 8 in y direction, so minus 8 would be here. Let us assume that minus 8 is here, and plus 3 in I direction, so plus 3 is here. So let us represent the graph like this. It will be something like this. Making theta angle. This has a length of 8 units and this is 3. So we can find out tan theta. tan theta is given as 8 by 3, so we can find out theta as tan inverse of 8 by 3, and that will give us approximately 70 degree. So the velocity vector is making 70 degree in the fourth coordinate with respect to x-axis. Thank you.
The question says that a particle starts from origin at time t equals to 0 seconds with a velocity of 10 j cap meter per second and moves in the xy plane with a constant acceleration of 8 I cap plus 2 j cap meter per second square. So the question concerns with the motion of a particle in a plane in which the velocity is directed towards the y direction, because j cap, that is a unit vector along the y direction, has been used, and the particle starts from t equals to 0 second with a constant acceleration of 8 I cap plus 2 j cap meter per second square. So let us first write the details about it. Initial velocity is given as 10 j cap meter per second, and acceleration, that is constant, is given as 8.0 I cap plus 2.0 j cap meter per second square. Now everything is in meter and second, so the units are convenient. Let us begin solving the question A. At what time is the x coordinate of the particle is 16 meter? What is the y coordinate of the particle at that time? So at first we will have to find out at what time is the x coordinate of the particle as 16 meter. So we see that the initial velocity in the x direction is 0, so the acceleration is, and also the acceleration is 8 I cap in the x direction. So equation of motion says that s equals to ut plus half a t square. Now u here is 0 because initial velocity along the x direction is 0, plus, so it would be 0 plus half. Along the x direction we have acceleration of 8 meter per second square, so the value of a would be 8 into t square, and the displacement given is 16 meter. This will be equal to 16 meter. Now solving for t, we will get t equals to 16 into 2 divided by 8, that is square root of 4, or 2 second. So at 2 seconds the particle, the x coordinate of the particle is going to be 16 meter. Now we have found out at what time it is going to be 16 meter. Now the second part says that what is the y coordinate of the particle at that time. So again we will use to find out the position of the y coordinate of the particle, we will use this equation. Now for the y axis, now we have the initial velocity along the y axis as 10 meter per second, so it would be 10 multiplied by time, that is 2 seconds, plus half. Acceleration along the y axis is 2 j cap, so it would be 2, time is 2 seconds, so 2 times 2 meter. Now that will yield out to be 20 meter plus 4 meter, that would give us 24 meter. Now the second part of the question says that what is the speed of the particle at this time. Now it says that at time t equals to 2 seconds, what is the speed of the particle? So we will have to find out the velocity at time t equals to 2.0 seconds. So velocity at any time t is equals to u plus at. The velocity vector here is, let us first consider the x-axis, the velocity along the x-axis. Initial velocity along the x-axis is 0, so it is going to be 0 plus acceleration is 8 times time 2 meter per second, it is going to be 16 meter per second. Vx, that is the x component, and Vy similarly it is going to be 10 plus 2 multiplied by 2 meter per second or 14 meter per second. Now the velocity vector at 2 seconds is going to be 16 I cap plus 14 j cap. Now we will find out the magnitude of the velocity vector like this: 16 square plus 14 square. Now that will give us something about 21.26 meter per second. So the magnitude of velocity at time t equals to 2 seconds would be 21.26 seconds. Thank you. 21.26 meter per second. Thank you. The question says that I cap and j cap are unit vectors along x-axis and y-axis respectively. What is the magnitude and direction of vectors I plus j cap and I cap minus j cap? So we have to find out the magnitude and direction of these two vectors. So let us construct a coordinate axis first. Let this be x-axis and this be y-axis. So I cap plus j cap would be somewhere with this unit 1, it would be here. Now we can represent it as I cap plus j cap. It is making an angle of theta with the positive direction of x-axis. Now along with this we can also construct I cap minus j cap. So I cap minus j cap has positive 1 component in the positive direction of x-axis and negative 1 component in the y-axis direction. So positive 1 unit would be this and negative 1 unit would be this. So its head would be somewhere here. So this can be constructed like this with an angle of phi. So we know that this is 1 unit, this is 1 unit, and also this is 1 unit in magnitude, and this is 1 unit in magnitude. So finding out the angle theta and phi, we have to find out the direction of the vectors. So theta can be said to be tan inverse of 1 or 45 degree with the positive direction of x-axis in anti-clockwise direction. Now phi can be said as tan inverse of minus 1. Now this will give us either minus 45 degree or we can say clockwise direction 45 degree. So the second vector is lying in the fourth coordinate, whereas first vector is lying in the first coordinate. Now we have found out the direction of these two vectors. Now we have to find out the magnitude of these two vectors. So magnitude of the vector, we know the formula for the magnitude of addition of vectors. So if we have two vectors A plus vector B, then its magnitude is going to be under root of A square plus magnitude of B square plus 2A B cos theta, where theta is the angle between these two vectors. Now this would give us 1 square plus 1 square, as cos theta would be 90 degree and this would result out to be 0 because I cap and j cap has 90 degree angle between them. So this will turn out to be root 2. So the magnitude of both the vectors is going to be root 2. Now the second part of question says that what are the component of vector 2i cap plus 3j cap along direction of this first vector and this second vector. So to find out the component of one vector on another vector, we need to find out the unit vector along that direction first. So if we have to find out the component of vector A, on vector B, so we will take the dot product of these two vectors, provided that vector b is a unit vector, then the dot product of these two vectors will give the component of vector a on vector b. So simplistically we can say that vector a dot product of vector b divided by the magnitude of vector b, because if we have to find out the unit vector along the direction of vector b, then we can divide it by its magnitude. It will give us the vector component along this vector. So here vector b is this, either this vector or this vector. So let us first consider the case of I cap plus j cap. So vector a is 2i cap plus 3j cap. Now as per the formula above, we can say vector a is 2i cap plus 3j cap dot product of this vector I cap plus j cap divided by its magnitude, that is root 2. Now we know that the dot product is simply the product of its component, summation of products of its component. So it would be 2 plus 3 divided by root 2. This will give us 5 divided by root 2. So vector a has, this vector has this much component along this vector. Now in second case we have I cap minus j cap. Now similarly we can find out 2i cap plus 3j cap dot I cap minus j cap divided by root 2. Now that will give us 2 minus 3 divided by root 2 minus 1 by root 2. So minus 1 by root 2 is the component of vector a along this vector I cap minus j cap. Thank you. The question says that for any arbitrary motion in space, which of the following relations are true? So here question is saying about the arbitrary case. It is not saying whether the acceleration is fixed, whether the velocity is constant, anything else. So the motion can be of any kind. So the first option is average velocity equals to half of velocity at time t1 plus velocity at time t2. So this contradicts with the very definition of average velocity, which says that v average is equals to total displacement divided by total time. Now that's why it's false. In the second case we have v average equals to position vector at time t2 minus position at time t1 divided by time interval. So this is the correct definition of the average velocity, because the difference in position vector will give the displacement, therefore it is correct. Now third option is v at time t equals to u plus at. So we know that this is the equation of motion. In chapter 2 we have studied that v equals to u plus at. So as per the given case in this question, arbitrary motion, acceleration can be fixed or cannot be fixed, but this equation is only true if acceleration is fixed. Therefore we can't say that it is always going to be correct, so it is false. Now in fourth option we have position vector r equals to r naught plus v naught t plus half at square. Again this is the equation of motion, s equals to ut plus half at square. So here it is saying that r at t minus r at 0 equals to v naught plus half at square. Now this is the displacement and this is initial velocity multiplied by time plus half a t square. Here again acceleration is constant, which is not with the case of arbitrary motion, as it is not clearly stated. so it is not always going to be correct, so it is false. Now in fifth option we have average velocity equals to velocity at time t2 minus velocity at time t1 divided by the time interval. This again is the very definition of average velocity, so this is correct always. Thank you.
The question says that read each statement below carefully and state with reasons and examples if it is true or false. So there are 5 statements about a scalar quantity, and basically we have to say that which one of these 5 statements is true. Now the first statement says that a scalar quantity is one that is conserved in the process. So this statement means that, let us take a case of a moving particle. So it starts from position in some space coordinate. It starts from A, and after traveling it moves, it again resides to A. Now this is a whole process because the starting and initial phase are same. Now for a scalar quantity, it is asking if it is conserved or not. So let us take a scalar quantity here, that is a distance. So we know that since when it started it was at distance 0, and when it ended it must have some positive distance that it has covered. So we can't say that the scalar quantity of distance is conserved in a process. So this one is false. Now in second we have a scalar quantity is one that can never take negative values. So this is false because scalar quantity can have negative values. For example, work is a scalar quantity and we have negative work done. So this is also false. And in C we have scalar quantity is one that must be dimensionless. So this is utterly false statement because distance, speed, these all are scalar quantities, but they have definite dimensions. So this is false. Now fourth, we have a scalar quantity is one that does not vary from one point to another in space. So this is a false statement because let us take the case of distance again. In space coordinate, obviously the distance from a particle, let's say the origin, the distance from A to B, or distance of A from point O and distance of B from point O is different. So it does vary from one point to other in space. Now in fifth we have a scalar quantity is one that has the same value for observer with different orientation of axes. So let us assume a case of vector and a scalar. So this is a coordinate axis and this is a vector OA and this is vector OB. If we take component of OA, vector OA on x-axis, it is going to have a value that would be different from the value of its component on vector OB. So we see that if we have changed the orientation of the base vector over which we have to take the component, its value has also changed. But this is not the case with a scalar because it has got no directional sense. That is why this statement is true, which states that a scalar quantity is one that has same value for observers with different orientation of axes. Because it has got no sense of direction, it is just a value and it remains fixed irrespective of any direction. Thank you.
The question says that an aircraft is flying at a height of 3,400 meters above the ground. If the angle subtended at a ground observation point by the aircraft positions 10 seconds apart is 30 degrees, what is the speed of the aircraft? So the question says that
an aircraft travels from point B to C and the ground observation point is at point A. Now when the aircraft traveled from B to C, it casted an angle of 30 degree on the ground observation point. So we can assume this as a triangle situation. Now ABC would be an isosceles triangle. Now AD is the bisector of this angle BAC that the aircraft subtended traveling from B to C. Also we know that the height of the aircraft is 3400 meter. So AD would be 3400 meter. This height would be 3400 meter. Now we know the property of bisector. If it is bisecting, then it would be 15 degree both. Also these two sides should be equal because both the triangle will be similar now. So we can say that the tan 15 degree would be CD divided by DA. Tan of this angle would be perpendicular divided by base, so it would be CD divided by AD. Now using this ratio we can find out CD. Now we have to find out the speed of the aircraft. So for the speed of the aircraft we need the distance it has traveled. Speed equals to distance divided by time interval. Time interval is 10 seconds. We all know it has been given. We have to find out distance, and this distance can be found out by finding out the length of BC. Now finding out the length of BC, we can simplify it as twice of CD, as these two sides are equal. So now CD will be equal to the AD times tan of 15 degree. So now if we find out tan of 15 degree, it would be somewhere around 0.3. Now substituting these values, we will get BC equals to 1822 meter. BC equals to 1822 meter, or the aircraft traveled 1822 meter in 10 seconds. Now for finding out the speed, we have to divide this distance 1822 meter by time interval, that is 10 seconds. So we will get 18.2 meter per second, or if we want to round out to the closest integer value, then it would be 182 meter per second. Thank you.